Welcome, this is Professor Merrill Lichty. In this video we're going to be looking at the normal distribution and the logic that's used to solve problems involving the normal distribution. We'll also take a look at some of the software that we're using in this class, Minitab and Excel. And so let's just jump right into it. Here's a typical normal distribution question. Stanford Binet IQ scores tend to follow a normal distribution with mean 100 and standard deviation 16. And IQ tests are actually standardized, so this is true. If we were to choose someone at random, what's the probability that their IQ score is 124 or less? And if we want to think about that in terms of the random variable x, what we're saying is, what's the probability that x is less than 124? Now, whenever you're going to do a problem like this, you should always draw a picture. And here I've got a picture drawn by a computer. And the thing you want to keep in mind about continuous random variables is that the probability is just equal to the area under the curve. So if I can draw the picture correctly, then I probably will get the question right. So all we're trying to do here is find the area under the curve to the left of 124. So there's a few ways that we can do this. We can use Minitab, we can use Excel, or we could use the standard normal z distribution and a table that goes along with that. And there will be another video covering that. We're going to be dealing with a less than or equal to probability, and this is what we call a cumulative probability. So we want to use a cumulative probability function. In Minitab, you can go to the Calc menu, Probability Distributions, and then Normal, and you get a little window that looks like this. And all we're going to do here is select cumulative probability. We just mentioned that's what we're looking for. Probability density, we're actually probably never going to use that in this course. That just tells us the height of the function. And when we have a continuous random variable, the height of the function does not tell us the probability, it just tells us the height of the function. So we want cumulative probability. If we put in a mean of 100, standard deviation of 16, and then the input constant is the 124. When we click OK, we get this output: normal with mean equals 100, standard deviation is 16, x is 124, so the probability of being less than or equal to that value of x is 93.3193%. So what we've just done is kind of the big deal about the normal distribution. If you want to find the probability associated with a normal random variable, you use a cumulative probability to find the probability of being to the left of that. And we'll see in a few slides how we can apply that other places. If we don't have Minitab available or just want to use Excel for some reason, we can use the function norm.dist, which takes in the x value first, and then the mean, and then the standard deviation, and then finally the last fourth parameter there. If you want a cumulative probability, needs to be set to either true or 1. If you put that fourth one as false or 0, then you get the height of the function. And you'll see that if you try this in Excel, you will get exactly the same value, 0.933193, which says, again, there's a 93.32% chance that a randomly selected individual will have an IQ of 124 or less. Let me just make a comment here. You should be familiar with the empirical rule by now, which basically just says the distance between the mean and the point of interest measured in standard deviations is going to give us the probability that we're interested in from a normal distribution. And this distance is called a z-value or a z-score. So we take the distance from the x value 124 to the mean, and that's going to be 24 IQ points. So notice that's still in IQ point scale, and if we want to divide that by the standard deviation of 16, that gives us 1.5 standard deviations, or in other words, a unit that has, or a measure that has no units, because the IQ points get canceled out in that ratio. And this is the z-value. So what we're saying here is 1.5 standard deviations above the mean or less has about a 93.32% chance of happening. And in the background, that's the number that's being used by the computer to actually calculate the probability. The function can be viewed as z equals x minus mu over sigma, and if you simply plug those numbers in, you get 1.5. So let's expand this question to look at the probability that someone's IQ is greater than 124, and we would write that p of x being greater than 124. And again, I've drawn the picture, and I want to know what the area is to the right of 124. Well, I just figured out that the probability of being less than 124 is 93.32%, and so that means the probability of being to the right of 124 is going to just be 1 minus the probability of being to the left. And so you want to keep in mind that the software and the normal table only gives us left tail probabilities. So if we want to know the probability of being in the right tail, or the right of some number, we're going to have to do some simple arithmetic. So this says there's about a 7% chance that someone will have an IQ greater than 124. Okay, so what if I want to know the probability of being between two numbers, 90 and 124, for example? Again, the software only tells me the probability of being to the left, and so we already know that the probability of being to the left of 124 is 0.9332. And we can use Minitab or Excel or even the table to find the probability of being less than 90. And once we have that probability, we can do simple arithmetic again to find that 0.6672 of the area is between 90 and 124. So there's about a 67% chance that someone will have an IQ between 90 and 124. So let me re-emphasize that it's very important that you understand how to do everything that we've done in this video up to this point, because everything else we do in this class is going to be based on this. Almost everything. The question often comes up of the inverse cumulative probability. So in other words, here we have Bob, and Bob tells us that his IQ is in the 92nd percentile. And so what does that mean? That means that 92% of people have a lower IQ than Bob, and 8% have a higher IQ than Bob. And we want to know what that IQ is. So what is Bob's IQ? So it's not too difficult to draw the picture. Here we have a mean of 100, standard deviation of 16. We don't know what the x value is, the cutoff point, but we do know that the probability of being to the left of that is 0.92. So this should give us some idea that his IQ is going to be, well, we know it should be less than 124 because we just saw that 124 has 93% of the area to the left of it. So it should be a little bit less than 124. But the question is how much less? If we go back to Minitab, we can use the same functionality, calc, probability distributions, normal distribution. But now we pick inverse cumulative probability and put mean of 100, standard deviation of 16. And now our input constant is going to be the proportion to the left. Remember, we're always doing things with the area to the left. And so in this case, we have 92% of the area to the left. And when we click OK, we see that the x value is 122.48. So Bob's IQ is about 122. You can get the same thing in Excel if you use the function norm.inverse, and then you put in the percentile, 0.92, the mean, and the standard deviation. Okay, so let's look at one more inverse cumulative probability distribution question. In this case, we're being asked to find a symmetric interval around the mean that captures 75% of all IQ scores. So what does that look like? It looks like this. We have 100, that's the mean right in the middle. You know the area is 0.75 in between x1 and x2, and we want to know what x1 and x2 are. So let me remind you again, software works with cumulative probabilities. So that's the left side of the boundary. And the total area under the curve is equal to 1, because anything that's going to happen has to happen between negative infinity and infinity, so that area under the curve has to be equal to 1. So the total area in each of the, or in the tails, is 1 minus 75%, so we have 25%, and that's divided between the two tails. So that means each of the tail areas have 12.5% of the area. And you can see that labeled here. So if I add up all those numbers, 12.5% plus 12.5% plus 75%, that equals 100%. So that means that to the left of x1, there is 12.5% of the area. So how do we find x1? We go over to Minitab again and put in 116. Input constant is now 12.5% or 0.125, and make sure we select inverse cumulative probability, and we find out that 81.59 has 12.5% of the area to the left of it. Okay, so we'll label that. And now we have a couple of ways that we can find x2. The first one is using symmetry. Because we have a symmetric bell-shaped distribution, we know that 81.59 is negative 18.4 IQ points below the mean of 100. So if we take that same distance and add it to 100, then we get 118.4056. That's one way. The other way we can do this is to use the inverse cumulative function again, and note that we have, instead of 75% of the area to the left of x2, we actually have 87.5% of the area to the left of x2. So use Minitab or Excel, and we get exactly the same value. So we would say that 75% of all IQ scores are between 81.59 and 118.41 IQ points. So that's it for this one. Go and make sure you understand how to do this stuff with the practice problems. Get familiar with Minitab and Excel, and we'll see you later.